Welcome everyone, welcome to our next episode. And if you're following our channel, you already saw the first episode where myself and Professor Adolfo here talked about our backgrounds and our history. So we're going to move on to the next episode where we're going to talk more about the actual history of building automation as we know it. And I really, once again, thank you very much, Professor, for joining us today.
Yes, thank you very much.
Yeah.
Yes, I can say that when I started my engineering degree, I had no idea what was an integrated circuit. I worked at my the former school with electronics, and we built a radio with transistors. We soldered that. And when I came to the university, I saw the first integrated circuit. And I said, oh, what is this? Oh, we are putting a lot of components inside. And then after a short, I started working with 6502. It was the Apple processor. That was the first processor. I started to programming an assembly language. And after that came 8080 and so on. And at this time, this was the middle 80s, we had no network, no internet, no connection. Everything was standalone, and Apple, my Apple II computer was a big sensation with the graphics, with the mouse and making pictures. But at this time, we had no idea what would come. And I have seen then at this time then BitNet, that was a voice with you use the telephone to make a connection and then download the weather prognostics or so simple things. And then I remember 1992, we had then Mosaic. This was the first browser for the internet. And then at this time I also started Microsoft Windows 3.1. And then at this point, the world started to be connected. And it was only a matter of time that we go to Internet of Things, or as I like to say, connected things, not internet, not only internet. You have Zigbee, you have many other protocols, but we went from a separated engineering in the company for the Companhia Siderúrgica Nacional, a lot of computers, but standalone, not communicating with anyone. And now we have the new reality that everything is connected. It's internet of everything, or the connection of everything. And the buildings are part of this move, because each building used only electrical installation. You have the switches to switch on the lights on and off. You have the switches for the air conditioning. And the logic was also all built by this cable logic. And then we moved to the cable, KNX, and other Modbus with where the energy went in different conductors as the information. We separated.
The two,
And then, now, 20 or more years, wireless is very important for retrofitting, for old buildings. For new buildings, I think the best solution is cable, because wireless is nice, but every time you have trouble connecting and reconnecting and so on. And so cable is the best way for new buildings. But the retrofitting market is huge. You have a lot of opportunities there. And the difficult point, let me say a little more, is that the guy that builds the building is not the guy that pays the bills for the air conditioning. This is a huge problem.
It's a key point.
Yes, because for example, we have developed a hybrid air conditioning system, evaporative plus compressor based, so that we change when we can. We use the evaporative
side,
Yes, and then we evaporative gives more humidity in the air, and the conventional, it dries the air, and so we change. But no one likes to use this because the cost
is slightly more.
The cost is not of the guy that built this. The cost is of the guy
that uses the building.
Yes, that uses the building. The payback is not for the guy that builds. And so this is a huge mind problem that the guy say, I only see my profit.
That's it.
And not the lifetime of the building.
It's very interesting as you build up that history of automation. Now, that history that you described, to me, is more in countries like Brazil, not necessarily what was the US history. Because in the US history, to give you an idea, Johnson Controls as a company existed from, I think, 1885 or something. I mean, they've been there for 100 and so many years, right? And the initial control systems in the United States, so before the computers came in and you were using electronics to control stuff, in the United States, they were using pneumatic systems. And the pneumatic systems were basically, because in the United States, they have what they call ducted systems. So even in houses, they have an air handling unit and they have ductwork that goes to each of the rooms, right? Now, you can have an argument about whether it's the best thing or not, but this is what they have, right? And they have it in all the main buildings, and it's based off indoor air quality, bringing in enough amount of outside air, and all these
chiller-based
systems, right? And as a result of that, you needed to control. And to control, they used pneumatic systems. And pneumatic systems literally had a compressor in the mechanical room where the chiller was, and you would have all these copper wires, copper tubing, right? Tubing. And you would have copper tubing with air that goes to the thermostat, and in the thermostat, they had a little bimetallic strip. And based on the temperature, when the bimetallic strip moves, it opens up the orifice of the air, and and then it makes the adjustment accordingly. So based on that, it goes back to a valve, and then the valve opens out and closes, and all of those stuff. And I started off with Johnson Controls in, I'm trying to remember now, I think it was 98. I started in 1998. I'm almost sure it's 1998, or either 98 or 2000. Now I can't remember. But I started around that time frame. And that time frame was when they were switching from pneumatic systems and now introducing the DDC systems to the computers that you talked about, right?
Yes.
So what was interesting is that the pneumatic systems themselves, as they started, it was a standalone system. So it was not connected to anything but the control system. And you had a compressor in the mechanical room and it ran. Then as they switched over to DDC, it now became a computer. It became a Windows-based computer that would sit in the mechanical room. And from there, you had controllers that were located in each of the key areas, and you programmed the controllers and you were controlling the system. Now, what happened from there on out is 2000, I think by 2005, 2006 timeframe, you started hearing about network solutions, where rather than having computers stand alone, you had a network. And they would have the IT room and they would fill it up with all these network drives. So then came the idea, why do we need a separate computer? Why don't we just put it on the network? So back in 2005, 2006, they went down this path with IP controllers. They started to want to go towards that direction, and they started putting these things on the network, right? And it was, instead of having a dedicated system, now you had connections specific to within the servers in those IT closets. You will connect it to, you have your BMS system connected to it. And you fast forward a few more years, and you get to the point whereby they said they had cloud-based systems, and at the same time, all these protocols were developing, Zigbee coming in with the wireless solutions and everything else. BACnet was there, Modbus was there. BACnet was developed during that period because initially the major players like Johnson Controls and Siemens and Honeywell, they had their proprietary language that they used for the controls. And then they came up with BACnet as a solution that it could have some level of communication from one protocol, from one manufacturer to the other. And then it went into the cloud-based systems. And once it got to the cloud-based systems, this is where we are now. We have cloud-based systems in the cloud, but then it has also exposed the fact that now you're running your systems alongside other systems in the building, including your HR, including your payroll, and then the cyber threats and cybersecurity issues started coming up all along, right? And it is interesting how it's evolved, and it's very interesting to hear you speak that for new buildings, you want to be able to have it connected by cable,
yes,
right?
Yes.
And yeah, go on.
Yes, it's very interesting that very few ideas are really new. And for example, in 1948, there was a book from Norbert Wiener called feedback, not feedback, yes, about feedback control systems. And now the book was cybernetics. The cybernetics was a word from the 50s. The new thing should be cybernetics. And so the evolution started, and then people started to connect things, and then they called feedback control systems, digital distributed controllers. Now the people use the marketing word cyber physical systems. And this cyber came from Norbert Wiener, because you have now a computing capability and you have a physical system. Then the physical system could be the human body, could be the building,
could be
anything.
Right.
But the idea of working in closed loop is not new. And the ancient Greeks knew that, and the thermostatics from the body. And so, indeed, in the center, we have information processing acting on a physical system. This is then now with the cloud, but it's the same principle. It's the same. You need to measure it, you need to act. And so you have a target and set point. And you close it loop, you like to have thermal comfort, and so you are acting, but this is the same background, so to say, and we are only giving now different protocols, a lot of different protocols that are crazy, but the objective is the same: measure and act. This is how we can do, so to say.
Yeah, and talking about that closed loop system, right? The closed loop system. I am personally of the opinion that in general, when people talk about cybersecurity and cybersecurity threats and everything else, you've got to go back to the basics and ask yourself the question, why is it a threat? Why? And the answer is, it's a threat because you are connected to a system that has access to a lot of private information and private things, right? That is why it's a threat. So you can try to figure out all the ways to protect somebody from entering into that system, or you could choose to create a closed loop operational network, in which case it's not even connected to the rest of the systems, and then your cyber threat is not even an issue.
Yes,
and then that goes back to the pneumatic systems, right? That goes
yes. But a very interesting case is about K and X, because K and X, they say this is a closed system. Nobody's interested in the security. Who likes to know if the air conditioning is working or no?
Right.
And then it happened some 3-4 years ago.
Yeah.
Then the guys discovered that there's a key you can lock the system, so you can, and so they have ransomware.
Right.
They kidnapped the installation,
system. Right.
And say you have to pay $400,000 or I give you not the key back, and so they have to pay, and so. Only after that, the people say, you need to look for security because you can be locked out of your own system.
Yeah. So it's really interesting as that evolution from pneumatics and simple systems to more complex systems and where it's gotten, right? And I think what we should do is in the next episode when we talk about this, let's talk about where it's headed, right? Where is this going? And I will also take the opportunity then to tell you a bit more about where Grinnell came up and how Grinnell came up and why it came up, right? And it goes back to something you said early on in this conversation that we had about the person that pays to build the system is not the same guy that is paying for the electricity bills and the functioning of the system down the road. And that part of it is part of the construction history that I think needs to be relooked at, whereby you can disrupt the way, and when I say disrupt, transform the way that you go to market and how you go to market. And that is the reason why KLPD exists.
Okay.
So it's funny you brought it up because you and I did not have we've not had any previous conversation.
No.
We met today, right?
A very important say in Brazil is that the most sensitive organ of the human body is the purse.
Yes, yeah, that's a great way. That's a great way to end this episode. And if you like what you heard, please go ahead, subscribe, follow, comment. If you think differently from what myself and the prof here are thinking in terms of the history of automation, you want to add some comments to it, please go ahead and add the comments and we'll engage with you and we would love to have your opinion and thoughts on it. Thank you everyone and we'll see you on the next episode.